welcome up Mr. Coomer.
So I always like to do a very cheap survey with my audience before I start to check out who knows what. Lots of new people this year. It's very exciting because we've been seeing a huge number of brand new customers over the past few years. So I'm going to talk about DDN's EXAScaler product primarily, and then Sven is going to do a wonderful job of talking about DDN Infinia after me. So just to set the scene, how many people here can kind of know what DDN EXAScaler is? Okay. And how many know what Infinia is? Right, fairly modest, fairly modest. So we'll start very slowly, I think. So who is running EXAScaler in this room? Probably a few. I see some friendly faces over there. So it's a parallel file system, and it's designed for massive scale. And we've been running it for many, many years. We acquired a very fantastic team of developers a few years ago, and ever since then, we've been really running with it, and we're a major deployer of these kind of file systems. And really, as we've seen before, NVIDIA is one of our major customers, and they've been influencing us, and our joint customers have been influencing us rather a lot over the past few years. And the customers really are across the full gamut of your industries here. I suspect we have people from life sciences, from finance, NCPs, and they're all represented as part of the EXAScaler customer base. So why do they choose EXAScaler? Well, I think we've kind of heard it, right, from various people. I'm kind of summarizing it here in just one slide. We build this technology which accelerates GPU traffic, so it means that the GPUs are more productive in running what you want to get out of it. Typically, that's a model being trained or an inference workload being inferenced, or increasing the number of tokens per second. We do that by removing the I/O wait time. So GPUs are no longer waiting for anything. They're always being pumped with data, whether that's pulling the data models and the data itself into the GPU memory, or whether it's checkpointing this very large-scale model at really large scale down to storage because we need to keep that model safe in case there's an interruption in the service whilst you train this model over possibly weeks, possibly months. So checkpoints, model loads, data loads, and doing it all with the minimum of footprint. And that's footprint in terms of power, physical footprint, network footprint, everything like that. So the biggest performance in the smallest amount of space and power. Now we saw in that video just then, presumably everybody noticed the fantastic DDN bezels in those racks. In that video is actually the first generation, the AI400X, which we built for NVIDIA, and they deployed in their Selene system 6 or 7 years ago. Then they deployed the X2, and then now we're announcing the X3, really designed for Blackwell. So you can see it's a 2U appliance. It pushes 150 gigabytes a second into the network. So there's no complexity here. That picture is a complete parallel file system. That's all you need, one of those. Of course, many of our customers have more. They just scale linearly, but that's all you need. And the reason we're bringing it to market now is because NVIDIA is advancing their GPU technology extremely rapidly. And we're seeing a several-fold increase in the advent of Blackwell in the memory footprint, the amount of data that can be moved into memory of these GPUs in this Blackwell generation. So we as storage vendors need to up our game and match that demand so that you can keep the footprint small and keep those GPUs busy, despite the fact they're much faster. That means that today we've got a very broad range. If you're a cloud provider, you might want maximum performance in order to drive those GPUs for large-scale training. And here you see the X3 products. And you'll also see an X3i, a super fast metadata capable system coming later in the year. You'll see our current generation, the X2s, which are also QLC enabled, so different levels of flash for different budgets and different performance types. And we also have these hybrid systems which use traditional HDDs. More and more of our business is moving to flash, but still, if you want a low-cost archive or a low-cost large capacity system, then we can choose to use HDDs. So really, in this picture, we're spanning this three-dimensional graph where one axis is cost, another axis is performance, another axis is capacity. We can place you anywhere in those three dimensions, depending on your specific requirements. We can build the fastest TLC flash system in the world, and there we're pushing 20 petabytes of flash in a rack and 3 terabytes a second of throughput. On the other end of the scale, we can give you that same 20 petabytes at a much lower budget and a much lower performance. We can use that for archive. So for ever there are customer requirements, we've got something to fit. And the really cool thing is we can actually mount all this as one file system. But really, that's hardware, right? Obviously, it's hardware plus software, but our development team, and a few of them are in the audience today, so if you want to speak to them, you can. They'll be working very hard on the software, which is EXAScaler, the very fast parallel file system that we've been developing for many, many years now. The latest release of 6.3.1 came out in August, and we're just about to release 6.3.2, and they all attempt to satisfy all of these requirements we see from these new customers in particular around multi-tenancy, around security, around simplicity, around keeping things online all the time. And for every one of those requirements, we now genuinely check the box. Online upgrades are in the system, so you can have a massive scale supercomputer, keep everything online, and upgrade those systems. That's critical for us and for customers, obviously. It's critical for customers because they want to keep things online, but it's critical for us because we want to help them get to the latest version, get to the latest features without downtime. So let me go through a few of these and give you some ideas about what's really inside. So firstly, the parallel file system, what's special about it and what distinguishes it from other file systems that use NFS or some kind of NFS. Really the cool bit is at the top there. You see it says intelligent clients. What's intelligent about it? We've talked about data intelligence systems, but what's intelligent about the DDN EXAScaler client? And the answer is it knows where the data is. And that sounds like an obvious thing for a storage system. It should be able to know where the data is. But the clients know where the data is. And that allows us to shortcut a huge number of operations that other storage systems have to go through. And that's why we have this oil efficiency. So the architecture of a parallel file system is critical in reducing the infrastructure while keeping that performance up. But efficiency doesn't just stop there. We've been trying to build a new sort of data reduction system. And people have probably heard of compression and dedupe and things like this in this audience. Who has heard of compression? Is everybody with me? Hands up, please. Get some exercise. Most people. Now, the problem with most compression is you switch it on, and if you're really looking carefully, you'll notice the performance drops, sometimes really badly. So what we've done is architected a data reduction system that doesn't have that feature. And we do that by running that compression client side. We tap in to the kernel compression mechanisms to allow you to reduce the data with literally zero impact on the storage performance. So our customers have 10,000 GPUs, 100,000 GPUs. So with that kind of pressure, other storage systems just would not be able to reduce that data in time. By shifting that workload into the application space, we can make this really scale. And we can see huge data reductions, up to 50x, with standard sort of text and log data, but typically you're going to see between 2 and 4x, depending on the data type. And as I said, you can do it very, very flexibly. You can even apply this on a single file if you want. You don't have to do the whole file system, but you can. File system, directory, or individual file, you can switch this on and basically get free super scaling compression. So new feature this year, already released. And as I mentioned, this is also a very cool attribute of what we do. This rack setup you got here, it includes a super fast flash TLC system. a pretty fast QLC flash system, an HDD system, protocol access for S3, NFS, SMB, plus our native parallel file system. But the crazy thing is, you can mount all these different media types just in one mount point. So the end user just sees, /my company. And within that, we can see the different pools of storage. And that's kind of incredible to be able to not only support those media types, but even to mount them. And they just use simple quotas to help move the data between these different pieces. So you can think of as a cloud provider, you can allow your customer to control how they move data between flash and archive in a very, very simple manner. Online upgrades, we've been working on this for years now, 3 years, and it's a tricky thing. We've got many components in here, and we need to speed things up. We need to do health checks. We need to orchestrate across a large cluster. We need to manage all the niceties of what happens when you perform an upgrade at very large scale, under the pressure of tens of thousands of clients. And it's taken a long time, but now released in 6.3.1 in August. Very much big thanks to the engineering team at DDN for getting that out. It was a big effort of many years. And we also added some extra tweaks. We got some very large customers, as we've heard, and often we always complain about this in our storage world, but we complain about the network. It's always the network, and people have probably heard that phrase before. But it's not, whilst it's not necessarily the storage's fault, we want to be able to help. We want to be able to find those network issues and help our customers get rid of them as soon as possible. So we built something called EMF Analyze. Basically run that program. It's going to test the network comprehensively. And before you even switch your storage on, you're going to know if there's any pressure on the network or any failed cables or any dodgy bits and pieces. So it's all about keeping our customers really into production very, very fast and very, very stable. And this new set of customers also want to see more. They want to see not just normal things about how fast the file system is running, but where the files are, how big the files are, how they're distributed along the file system, how all the different protocols are being accessed over time. They might want to use not DDN's proprietary system, great though it is, that's the pictures on this side, but they might want to use open source methods, Prometheus and stay open standards, and they can plug right into EXAScaler, and we'll support everything on the right as we do on the left and vice versa. So staying open whilst offering a proprietary interface is one of the keys. And talking about cool views, I mentioned this before at previous talks. Does anybody in the audience know what this picture is showing you? There's one, but he works for DDN. So this is kind of unique, right? Most storage systems can't tell you who's doing stuff to it. It's a secret. The storage just knows something's happening. It's either busy or it's not busy. But with DDN, our end users can see which users, which clients, which jobs are stressing the file system. And that's really critical if you're a cloud provider, for example, and you want to make sure that everybody's getting even access to the data and you're capturing problems very early. And actually, it's crucial anywhere. Anybody here with a large HP system who's running it will know that there's users out there who will do something weird. They'll create a script which creates 1 billion files in one directory in a fraction of a second, and then somebody will phone you up and say, what's going on with the file system? Uniquely with DDN, we can basically help you crack that puzzle by just looking at the screen. So a lot of advances. And essentially, what you'll see through 2025 is these same moves, simplicity, management, even faster, even better online upgrades, better visibility, all of those just continue through 2025, always with the increased performance and capacity as we move along. And the reason we do that is to make this pie chart even more compelling for our customers. And what we're really showing here is that NVIDIA has kind of convinced a large part of the planet that moving from CPU to GPU to run these new workloads gives you a huge amount of productivity back for your dollar, for your watt. And we say that by using DDN, we do even more there. We squeeze down the time associated with checkpoints, data loads, basically waiting for any I/O. We give it back to you in productive time out of your budget. Many of our customers' budgets run into close to billions of dollars. And so by giving back 20, 25% more of that resource, the cost of this storage really becomes not worth thinking about. because it's really outweighed hugely about the amount of resource you get back by eliminating those I/O waits. And we do all that in a very small footprint. As I said, with a parallel file system, with an intelligent client, we can squeeze all of this performance down to a much smaller footprint in terms of network, power, ports, etc., and really simplify the back-end network, allow you to scale from 500 GPUs to 1,000, 2,000 to 4,000 without network complexity. So, conclusion. 400X3 will be available very shortly. We'll be announcing it here, and it'll be available for you just in a few weeks' time from now. It's going to provide a huge amount of performance improvement over previous generations, but an even bigger performance improvement over the alternatives out there in the market. Moving data faster, 150 gigabytes a second in just 2U. Moving those checkpoints faster, 95 gigabytes a second in just 2U. And performing those all-important tokens per second for ultra-fast inference. Thank you very much.
Thank you, James.